Welcome to part 2 of standard normal probability distribution. So here in this video, we're just going to work with an example. On the last video, I was talking about just basically standardizing it. So in this video, that's what we're going to do. So let's go into the question. The mean weight of a certain species of rat was found to be 58 grams. So we found our mean to be 58 grams with the standard deviation, which is 8.5 grams. And then suppose that the weight of the rats are normally distributed and that 200 rats of species are randomly selected as part of a zoology study. Determine the probability that that a randomly chosen rat species with this species will weigh more than that one. So we're just looking for probability of X is greater than 64. So note that we have to transform X value to have P of Z of this greater than whatever. So now to transform that, remember our transformation formula is Z equals to X minus mean divided by standard deviation. So to get that, we just have to put that 64 in there. 64 minus 58 divided by 8.5. So to close it there, then we get our answer. Let me just quickly calculate it. I had my calculation here. So let me just quickly do this. 64 minus 58 divided by 8.5. Let's take 64 minus 58 divided by 8.5. So that will give you P of Z is greater than 0.71. So that's your answer for this part. Like what do you call it? Now you have converted that. You still need the probability. You haven't found the probability yet. So you still need to find the probability of that. So now from this point, you just apply probability rules. So this will be 1 minus P of Z less than 0.71. So now how do you get this value? So this is 1 minus the specific value at the back of the on this part. So we're looking for 0.71. So remember, if it's inside the Z value, if it's inside there, we look at the outside. We look at those Z value. So remember, you always look at those Z values. So we're looking for 0.71. So that would be this one, 7611. So now that is minus 0.7611. So now that will give you a good looking answer, which is equates to 0.2389. So that's the probability of selecting more than that. It's something that weighs more than that. So now to the next question. So they say how many of the rats selected per study weigh more than that number? So you're looking for rats that weigh more than that. So now you basically have to calculate the number of rats. So remember, n was given as 200. And now you have your probability, which is that amount. So that's the ratio basically of rats that will weigh 64 grams. So you can literally just say the number of rats equates to n times P of X. which is the probability of that. So that will give you what do you call it, the number of rats. So it will be 200 times 0.2389. So let me just calculate it. 200 times 0.2389, and that is 47. So you have 47.78. So since you can't have a point red, this will be nearer to 48. So that's the amount of rats that will be selected that weigh more than 64. So on the next question, they're asking you about the percentage. So they say the percentage of rats selected per study that weigh more than that one. We have a probability of px times 100%, which is times 100, that gives you the percentage. So now we can simply just say 0.2389 times 100, which equates to 23.89. That's the percentage that we're looking for. And then now you get your answer there. So they say how many of the rats selected per study as part of the study weigh less than 55. So now you're looking for P of X less than 55. Remember, you have to transform it to Z, which is P of Z. And now it's still less than, that doesn't change, but you have 55 minus 58. That's our mean, divided by 8.5. That's our standard deviation. And then this will equals to P of Z less than that will be a negative number, which is negative 0.35. And now you just need to just basically change this thing to positive. The less than is good, but you change it to positive. Remember, when you change it to positive, it's going to be greater than, which gives you that greater than, then it's going to be minus. It's 1 minus the complement of that one. So it'll be P of Z less than 0.35. So we're going to go to the P table and look at our value that we're looking for, which is 0.35. 0.35, that's 3 value, 6368. So now we have 0.6368. So now that's our final thingy. We have to just get our probability for minusing that. So it's 1 minus 6368, and that is 0.3632. So that's your final answer for that probability. That's your probability answer for getting something that lays less than 55. Okay, so the last question, or is it the second last question? These are just clowns. So this will be the last question. I'm just gonna do the top one first. This one. So the probability that a randomly chosen rat will weigh between 58 grams and that one. So let me just do it here. Let me just label it 4. No, that's 5. That will be 58. Remember, this is still X less than 64. So that's P. So we have to transform these values to Z. So we have P of, we can do it here, which is 58. 58 minus 58. Minus 58. 58 minus 58 divided by 8.5 less than Z, less than 64 minus 58 divided by 8.5. What did I do there? 8.5. Okay, so now this will be 0 less than z less than 64. Upon that will give you that 0.71, which we had in the first question. This is the first question, which gave you 0.71. And then now you have this equation, which you can easily work with. So that will be P of Z less than 0.71 minus P of Z less than 0. So we know that this one will give you exactly that number, 0.76, right? This one will give you 0.7611. So we have 0.7611 minus this one, we know it's 0.5. So 0.5, how do you know that? If you go to your table here, at 0, it's basically 0.5. That's 0, 0. So that's how you know there. So the answer will be 0.2611. That's your final answer there for 5. And then we have 6, number 6. So number 6, number of rats selected as per study that weigh between 55 grams and 64. So number of grams that weighs between they say the number of rats. That's the top question was asking for the probability. This one now is asking for the number of rats that weighs between those two. So now you have number of rats selected as per study that weigh between 55 and 64. So note that, don't confuse this 58 and that 54. That's the only difference there. So now for this one, you have to work it out again. So that's P of 5 less than X less than 64. So for this question, you're going to do the same thing you did on question 5. And then you basically have to transform it first, which is that 55 minus 58 divided by 8.5 less than Z less than, just write P here, less than 64. Less than 64, less than 58. 58 divided by, minus 58 divided by 8.5. So now you calculate your things. So now we did have 55 here, which was negative 0.35. So we can say this is P is equals to negative 0.35 less than Z less than 64. We know it's right here. It's 0.71, and now equates to P. We just have to get those difference. So that's Z less than 0.71 minus P of Z less than negative 0.35. So now we just have to make this one the right format because it's on the negative side. So to get this value, you just need to rearrange it using the rules that I showed you in the previous video. If you haven't watched it, just check it out. It's on the same playlist as this one. So this will be, just put it in brackets, so it will be greater than. So we know that it's just it's going to be that Z less than 0.35. And now we can just say distribute that negative sign inside this bracket. So it will be P of Z less than 0.71 plus P of Z less than 0.35, and then it's minus 1. So that's we know that already. So we know that 0.71 gives us 0.676. This is 0.7611, and then it's plus 0.35 gives you 0.6368. So this is 0.6368 minus 1. So you could already see that this is already over 1. So that's why that 1 will actually bring it back to discipline. Likely I'm actually at the end of the page and at the end of the question. There's 0.7611 minus 0.6368 minus 1. Made a mistake. So whenever you're doing probability, if you get an answer that's greater than 1 or less than 1, you have a big problem, because that means that you have a probability that's greater than 100. I mean, it's possible, but ideally it's not what you're supposed to work with. So now, are you done answering the question? No. You're looking for the number. So remember, the number was given by NO, the number of threads selected per study. So it was NO was given by N times PX, which is what we found here. So this will be 200 times 0.3979. So answer times 200, that's 79. So that gives you 79.58. So the answer will be 80. That's how many rats you're going to be dealing with. 80 rats. So that's all for this video. Tell me if you need me to do more questions, and then I'm just gonna do finding the value of A in the next video. I'm still on standardizing. So please like and share this video to your friends. So the goal is to make statistics very easy for students, and actually have the zealous, the love for statistics going forward. Please don't forget to like and subscribe to the channel, please. Thank you.